Today we start with surveys, so questionnaires, and the use of questionnaires and surveys in empirical software engineering. Here you find a couple of links. The first one is a link to a book that is quite comprehensive, as the title says, and it contains everything that you will see in this presentation and much more. Also, several theoretical and mathematical bases that may be useful. For you if you want to understand things better. And one is a paper more focused on surveys for software engineering. Throughout the presentation, I will link also some other presentations that are quite informative on this topic. So, what are surveys? As usual, we start with reading some definitions from the slide and then going ahead with examples. So, a survey is a method to systematically gather qualitative and quantitative data related to certain constructs of interest from a group of individuals that are representative of a population of interest. Constructs, we already know what they are. We've already studied. So also survey starts from from the idea of passing from a theory, translating it into constructs, and trying to understand what is going on in a certain population of interest. And the interesting thing here is that you deal with both qualitative and quantitative data. In the previous lectures, we've seen approaches that are mostly focused on quantitative aspects, like controlled experiments, and approaches like grounded theory that are based on qualitative aspects. Surveys are somewhat in between. Because on one hand, you collect, because first of all you can collect both quantitative and qualitative data, and whenever you collect qualitative data, you are most of the times oriented to do some frequency analysis, so some quantitative computation. Still, you may need some strategies from the qualitative data analysis world, and in particular from thematic analysis and grounded theory, to transform your qualitative data, so your answer in free form, into so-called codes, so in some form that can be counted, that is nominal and can be counted. We will see example throughout the presentation. Of course, you already know about constants of interest are the concepts that I want to evaluate, that in this case could be the usability of a certain tool, the developer's habit, etc. So anything that you want to assess, or something that you want some information about. For example, what are the most typical problems in the requirements documents of your company? The population of interest, which is the target population or population, these are just synonyms, is the group of individuals that is the focus of the survey. And it can be made of the Python developers, for example, or all the companies in a certain area, or Python developers from a certain university against the Python developers from another university. So you can imagine that you are submitting the survey, you are submitting the questionnaire to this different type of population of interest, or all the group of potential users. So the population of interest, you already see that can be composed of subjects, so users, but also entire companies. So the target of your survey and the topic of your survey can be the habits of a certain user, but also the characteristics, organizational and process-related characteristics of companies. As I highlighted already, I have also qualitative data here, but normally surveys are oriented to present statistics, and in principle, you can do also hypothesis testing, like in experiments, because you are gathering numbers, and you could, in principle, evaluate hypotheses. Although in most of the cases in practice, this is rarely done in software engineering. So you normally present just descriptive statistic. And the output, so, is normally quantitative, even though data can be also qualitative. In the individual of the population, in principle, can be also objects. So you can also do a survey about objects, so pieces of code. But in this case, we focus on the most common thing, that is surveying subjects, okay, surveying people. Survey can take the form of let's say, of a survey on object in the so-called discipline of mining software repositories, as we mentioned several times. Here, as I already used the term questionnaire as a synonym for survey, throughout the lecture, a survey here is a questionnaire. In general, you can think also that a survey can be delivered also by means of an interview, because you may stop people in a certain district or a certain area to ask them questions that are listed on your survey. So you administer the survey and you answer according to the answer of the interview. But in general, we focus on web-based questionnaires in software engineering. Okay, so surveys here is a synonym of questionnaire. Okay, yes, as I said, a survey can be carried out also with structured interviews. Why do we discuss surveys in software engineering? Well, they are quite important both in software engineering practice, because they can be useful to gather users' needs, which are the trigger for any software development endeavor. For example, if you gather the feedback from the user of your platform, you are basically performing a survey, like, are you satisfied? What are the problems? In which way can this service be improved? So in this case, also in software engineering practice, but in general, in the practice of market analysis, surveys are extremely common. In software engineering research, they are important to gather information about the practice of software engineering, so in companies or across companies, and to build general theories, because, as you remember, survey allow us to build theory that generalize across actors. For example, theory can be that a theory that can be derived from a survey can be that 80% of problems in software engineering are caused by poorly written requirements. Okay, here in this lecture, we are of course mainly concerned with the second type, so with software engineering research. But all the considerations that will be made are useful also for the software engineering practice and the market analysis. So you can use the guidelines that I'm giving you also for these other scenarios of application of surveys. Here we have our picture that we always show when we start a new strategy for empirical software engineering. And basically, surveys are sample studies. Sample studies, as we said, sample studies can be on subjects, are normally surveys, or on objects, and are normally strategies for mining software repositories, for example. Here in this diagram, surveys allow the maximum potential for generalizability over actors, because I am able to sample a large amount of people. Many more people can be involved in a survey than the people that can be involved in a laboratory experiment. And of course, more people and more diverse people compared to a field experiment or a field study, so compared to a case study in a single company. So these strategies are useful when you want to reach a broader audience, but of course you cannot be precise in measuring the behavior, like you do in your experiment, and you cannot collect so rich information like you do in a case study, in a field experiment, and in a field study, because whenever you do a survey, it's especially if it involves several people, 1,000 people, let's say, it is very unlikely that you get back to those people to ask clarification or to go in depth into certain topics. In addition, the survey needs to be filled quickly. So many things that you can gather in a 1 hour interview with people, you will not get them with the survey. At the same time, while in the interview, you can ask quite general questions and let the interviewee drive somewhat the conversation. In a survey, you have to be already clear from the start what you want to ask and which could be the potential answers. So it is as you already understand, is a strategy that you adopt when you have already some form of consolidated background, consolidated theory behind. Otherwise, you can perform a survey with completely open-ended question, like the one that you may have in an interview. But then you have to analyze the answers to this question, and it is very unlikely that either your question wasn't clear, and so the answer to the question is not clear as well, or your question was clear, but the person is answering going towards completely another direction, and you have no means to ensure basically that you gather and you get the information that you want to know, because there's no chance of clarification and interaction, okay, at least in the online survey. So let's see some examples, because I mentioned that you can survey companies, you can survey people. Let's start, for example, from the first point. Here there is an example of survey in software engineering in a company, and I have developed a set of requirements issues from a set of interviews. So I've interviewed people in a certain company, like 10 representative people, and I asked them what are the typical problems in requirements in the company, and I have performed a grounded theory. I've applied a grounded theory approach to list these requirements and the causes, and I want to understand how relevant are them, because now I have just a list to rank them, to understand which are the most relevant. I decide to submit a questionnaire, a survey, to the whole company, to all the employees of my company that somewhat deal with requirements. So in this case, my units of analysis are the employees of the company. Okay, the employees that deal with requirements and can allow me to rank this. So my goal in this case is to rank the requirements problem in this company for example, delivering a novel tool that allows to spot out these requirements problem, requirements mistakes in the document. So you see that there is a link between a study that is just based on survey and a possible study that would be a field experiment, because I'm delivering a tool and I want to experiment in the company. So this is to give you an idea that all these studies are oriented to build theory, but they are not isolated study. They are done for a certain purpose, and they can be followed by another purpose. In this example, you've started from some interviews. We decide to perform a questionnaire, and later on, we decide to perform a field experiments. If you have in mind all the strategies all together, you can scientifically go from the absence of knowledge toward building a theory and towards building a solution theory in a sound scientific way, and possibly more successful than in a random way. A second example is about a cross-domain population. For example, I want to understand which are requirements engineering problem, again, but from a larger population, not just from a single interview. And I decide to recruit participants from different companies or representatives that feel about the survey about their company. So in this case, the unit of analysis is the company. Each single subject from the company somehow act as the representative of the information about the company, not about themselves only. In this case, the single unit is the company. In an open source population, for example, I may want to understand which are the reasons for following some people, why a certain user in GitHub is following another user. And in this case, the strategy is different. I recruit the people from GitHub, and I ask open-ended questions, and afterwards I code them. So I perform a form of thematic analysis. So you see that there are different cases and different approaches. The really common thing between all these cases is that you want to reach as many people as possible. So this is the core thing. Generalizability over actors means that your design is your instrument is designed to reach as many people as possible, and reaching as many people as possible, of course, aims to generalize over context, but at the same time you tend to lose very context specific information. So you cannot have everything, like we said in the very first lecture. So in the surveys are to link, but to go back to our theory building, are approaches that are mostly deductive. So you normally start from some theory, at least some already built framework from which you want to deliver your questionnaire. So you have already, for example, developed a set of requirements issues from interviews. This is your theories, and you want to assess, for example, to which extent these are relevant or not within the company. So your approach starts from something and is deductive. But you need to apply inductive approaches, so thematic analysis, grounded theory, and coding in general, for open-ended questions, because you may have a question in which you don't have like a choice, but you can write free text. And in this case, you need to apply thematic analysis. This is a slide that we already saw, that is about the roles in software engineering. I wanted to remark it because in the end, you end up interviewing people according to their specific roles, because sorry, not interviewing, but surveying people according to their specific roles, and consider that different roles will give you a very different perspective. And it is good to remember which are the roles in a certain software organization. I don't go through all the list of names, but you have to remember here that the vision of our designers or developers may be very different from the one of the project manager or the functional manager or the organizational manager. Consider that the organizational or functional manager may be also people that do not know really about programming or software or software engineering, although because they may have a business background, okay, because they have different responsibilities. So they may see the things in a way, widely different ways from the viewpoint, with respect to the viewpoint of the designers, architects, developers, and testers. So remembering that there are different roles is important whenever you build a survey, because you have to have in mind a target population that is also a viewpoint on a certain problems. Remember also that companies do not necessarily include all these roles, because in a small company, probably the requirements analyst is the same as the developers and the designer doesn't even exist. or the top manager there is just one manager and the others are developers. Consider that some roles may be covered by the same person, and everything, of course, depends on the adopted software process. So we have seen this, we have repeated this many times, but it's worth remarking it that here we try to create theory and a list of names about something that changes every time. So depending on the process of the company, of the dimension of the company, etc., things may change. This is the general process for a survey that is made of planning, execution and analysis, and reporting. As said, please remember always that surveys are a hybrid between qualitative and quantitative studies, and these hybrid aspects you will see throughout the presentation. As usual, we start with research questions that are derived from some form of theory. So we start from a theory and then we derive research question. We have to characterize the target population. So we start already with identifying who are the people, so also the roles or the companies that are relevant for my research question. Then I perform the sampling, and I will present you the strategy for sampling. Last time we spoke about purposive sampling, so strategies for sampling that is appropriate for interviews, but in this case we want something more scientific, and we will speak about random sampling. Then you have to design your questionnaire. So first you select the population, and then you design the questionnaire. Then this is a little bit different with respect to experiment, if you remember, because in experiments you first design and then you recruit participants, because you need less participants, and the core is not really the participant, but the sound design to control the behavior. In here, it is really core to sample as many people as possible and to have representative answers. Then you decide the questionnaire, you pilot the questionnaire. I put in red the blocks that are key. Piloting is really, really important here because you have just one shot. So after you've written the questionnaire and you've delivered it, for example, through an email, this is your only chance, like, for example, to get 1,000 answers. If there is a mistake, then your study is flawed. And the information that you get them quickly, but at the same time it may be useless. Okay, so really crucial to pilot as much as possible, and we'll remark this later on. Finalize the questionnaire after gathering feedback from your piloting. Define measures for what you want to quantify. For example, you may have a link between some constructs and some questions, and you want to link them to specific measures of frequency to answer your research questions, and here it's the time in which you define these measures. Then deal with ethics and GDPR, so the European privacy norm that we will discuss briefly at the end of the lecture. Now you are done, you've written your survey, then you have to set the deadline for reply in online or email survey. You need to set a deadline that shouldn't be like too short or too long, 1-2 weeks maximum, because otherwise, if it's longer, people will not answer. If it's too short, people will not answer as well. Recruit and deliver the questionnaire, collect the answers, and then data coding and editing. So the data that you gather are not necessarily usable as they are, because you may have open data to code. Imputation and adjustments, because you may need to do some adjustments because, for example, the people didn't fill all the answers, didn't answers to everything. And data analysis and interpretation, you interpret your data and then you do the reporting. In this case, in the reporting, I listed basically what should be the structure of a report for a questionnaire. You start with the research question again. You explain the design, the sampling procedure, results and analysis, and the discussion in relation to research questions. And finally, very important, discussion of threats to validity, that in surveys are validity and reliability. You will see the characteristics of these threats, and you will appreciate the differences between threats in experiments, threats in qualitative studies, and threats in the surveys. So it is here we have basically less potential threats because we have two families, but much harder to control actually. So we said one key element after defining research questions is sampling your population. So selecting the people that you want to consider for the questionnaire. Also here, let's start from some terminology. So some definitions. Population is the universe of units from which the sample is to be selected. The term unit is employed because it is not necessarily people who are being sampled. The researcher may want to sample from a universe of nations, cities, regions, firms, etc. So unit of analysis, as you already mentioned, can be employees of the company, but can also be the companies in a certain area, or subjects that have a particular characteristic, like they are Python developers, or that you can focus on an entire nation. So population, in terms of it can be defined according to different units. In general, in software engineering, you focus either on developers or companies. But remember that there are many roles, and there is still open space for research, because not all those roles are considered in current survey research. Sample is the segment of the population that is selected for investigation. It is a subset of the population. Is the people that you select basically for your survey. The method of selection may be based on probability or non-probability approach. We will focus mostly on probability approach. Sampling frame is the listing of all units in the population from which the sample will be selected. It is an explicit list of units. Why? Because why we need this other definition and population was not sufficient? Because population is a vague concept, like all the citizens in a certain town, but the sampling frame is the actual list that is useful to you for reaching these people. So you can have, and it doesn't necessarily match with the population. For example, I can have the list of phone numbers for a town. This can be considered as a sampling frame, but it doesn't cover the entire population. Okay, so it's not the perfect sampling frame. So because in many cases the listing of all units is impossible to reach. So and in some cases it's not possible to reach also because of the population, maybe all the Python developers, you cannot reach them in any case. So the sampling frame needs to be something necessarily, in this case, necessarily much more restricted than the actual population. The representative sample is a sample that reflects the population accurately, so that it is a microcosm of the population. So you want to basically, based on a sample of the population, to infer information about the entire population in a way that the information that you derive from that little sample is sufficiently representative of the population, in the sense that if you repeat the questionnaire another time, you will get approximately the same answer. This is different slightly different from experiment. In experiment, in hypothesis testing, you're taking a small sample and show that it's different from the null hypothesis. Here is a different kind of approach, because the sample is larger, and your idea is that if you repeat many times the same sampling with within the same population, but with a different sample, you get a distribution of answers that is similar. The respondents are the subjects who responded to the survey. So let's see this in a picture that everything is clear. Population may be the developers. The sampling frame may be the emails of the developer. You see that it's not overlapping completely, because some developers may not have the emails of many of the developers, because, for example, I'm getting them from GitHub, and some of them may use a single address for different from different users, and vice versa. I may have multiple email addresses associated to the same user. The sampling frame, so, are the emails that I can get and they are associated to these people. The sample is the selection of people within the sampling frame, which is my representation of the population, and the respondents are the one that actually answer to me. So I sample, but I cannot expect that everyone answer my question. So this is a key to remember. Sampling frame. Here is a little remark taken directly from Wikipedia. You understood that there is a difference between the population, which is a somewhat vague concept, and the sampling frame, which is a list. So a list of people, and there is a definition of optimal sampling frame, because most of the time you get into a suboptimal sampling frame. In an optimal sampling frame, you cover all the population, because all the units have a logical numerical identifiers. All the units can be found, so the people can be identified. And these are other characteristics that I skip at the moment. Every element of the population is present once in the frame. So as I was saying, you cannot have a list of emails and you have two emails that refer to the same subject. That is not perfect. It's not the optimal sampling frame, of course. So that's why you have the sampling frame that can also be outside of your population, or can include people that are not interesting for your survey as well. No elements from outside the population of interest present in the frame. Also, this is not always possible, and as I just said, in your sampling frame, in your list, in the list that you have access to, you may have people that you are not interested in you are not interested as respondents of your survey, and the data is up to date. Okay. Other terminology, sorry, but we have to complete all this journey into terminological aspect, and then we go into more real thing, more concrete suggestion. Probability sample. So there are two ways of sampling. One is probability based, and the other is non-probability. Probability based is based on random selection. So from the population, I select randomly some subjects. There is a concept of sampling error that is the error in the findings that is derived from research due to the difference between a sample and the population from which it is selected. So sampling error is a difference between the people that you have and the actual population, so in the statistics that you derive. Non-sampling error, there are those that are due to differences between the population and the sample, but that arise from the deficiencies in the sampling approach. So the sampling error, you cannot get rid of it, but the non-sampling error that is associated, for example, to an inadequate sampling frame, no response, etc., you can somehow mitigate it, okay? And you can mitigate it by designing your questionnaire at best, and by sampling in the best way. There is possibility of non-response. As I mentioned, there are cases in which you don't get any answer, so you have to take this into account in your data analysis. So let's go into probability sampling, which is the most common type of sampling in software engineering, and is typical for market analysis and user studies, but also common for large software engineering studies. So random sampling simply means that I select a certain number of units, we will see how many, from the sampling frame in a random way. So I go in Excel, I have my list, my sampling frame, I order the list by random number with a run function, and I select the first ones. I can also do stratified sampling, so select a certain number of units for each identified stratum, so either developers or tester, in the sampling frame, and I do that randomly. Purpose sampling that we mentioned last time was used in interviews. Of course, here is since you are while interviews, you perform them also one after the other, and you can adjust throughout the process. Here, you prefer random sampling also because you have to select all the people at once. And let's go directly to how to compute the sample. I am not giving you all the theory behind this. You have to take as often some magic formula, but it gives you an indication on how to compute the sample size. SS is sample size. Z is related to the confidence level that you want to have. You remember this from our experiment. So how much confident you want to be on your results. In this case, if you set, and there is associated to the confidence level that you choose, there is a Z value, a Z score. I'm not going through explaining the Z score, but consider that once you have chosen a confidence level, you have also an associated Z score. So this number can be, this Z in the formula can be pre-decided. P is the sample proportion, and also this is another concept that I don't discuss here, but if you intuitively, if you want to maximize the sample size in the sense that you want to keep a conservative approach in which you say, okay, I take the maximum that the sampling formula allows me, the sample proportion is set to 0.5, because this leads in the formula to the highest sample size. And finally, the confidence interval. This is a concept that we didn't see, and is expressed in decimal points, so 0.04 or plus minus 4%. So this is to give you an idea on how to read, not just how to select the sample size, how to compute the sample size, but also how to read the results that you find in a survey. For example, you may find that the confidence level is 95% and the confidence interval is plus or minus 4%. Okay, what does this mean? That I am 95% confident that if I repeat the experiment, my result will be the same with an interval of plus or minus 4%. In other words, if the results of a survey is, for example, for a certain specific answer, 50% of the subjects are responding with a certain value, if I repeat the survey, the actual result can be between 46% to 54% of the people, with a confidence level of 95%. This is an example to explain you that that 4% is applied as a margin, as an interval, actually, in which your answer will fall if you repeat the experiment with a confidence level of 95%. So that's the how to say, a tricky aspect, but you understand that is reasonable because you are 90% sure that you fall in a certain interval that is specified by the confidence interval. This is how to read confidence level and confidence interval. When you have a population with a certain size, you can correct your number. So there is this correction formula. That number was a general case. In this case, you may have selected. You can infer maybe that the population is made of 10,000 units. And at this point, you select your confidence level and your confidence interval that are, you see, the numbers that are needed here. P is 0.5, C is 0.04, Z, you can select 19.6 for having 90% confidence interval. You have your sample size. You now say, okay, but I know how many subjects are in my population, and at this point I can derive my sample size. As you can see here, there are some examples, and there are radical difference for the same confidence level when you change confidence interval in terms of sample size that is needed. Because of course, if you want this segment to be smaller and to closer, so to be more precise with your evaluation, of course you need many more subjects. So in practice, it may be convenient to increase the confidence interval while keeping the same confidence level, because you see that the confidence level doesn't have as a strong impact like the confidence interval on the on your sample size. So 0.05 is acceptable as a confidence interval, and with a sample size of 370 people, you can infer quite good information for a population that is 10,000 people. This formula is can be computed in a systematic way. Let's say this valuation can be computed in a systematic way. What you have to remember is that if practically you are not able to reach that sample size, it is better if you work on the confidence interval than on the confidence level, because it allows you to reduce the sample size dramatically. In practice, how do you do it? Because here we are just speaking theoretically. In practice, if you want to check, for example, to survey people from GitHub, if your survey is concerned with developers, for example, you go in GitHub and you can submit this query, and you can submit the query that is written here. So copy paste in your browser, and you can download it. You can see which is the list of the most active GitHub user. You can get also many more information if you check out this GHTorrent project. So you get actual email from GitHub. If you want to check instead other type of professionals, so not developers, but for example business analysts or tests or other subjects, you may resort to LinkedIn. This is more complex, of course, because you have to approach people or create groups, polls, and it's harder to get subjects. While in GitHub, it is very likely that people will answer. In general, consider that for any sample that you take, the only 10% of the people that you contact will respond. In GitHub, you can reach 20%. So if you want to ensure that you gather enough data, contact as many people as possible and reasonable. So do in practice, if you need 40 people, if your sample should be 40 people, you have to contact 400 people. This is the idea. Okay. So let's take this example that is actually taken from a publication that you can check, and it's an interesting work that can give you some hint on how to do probability sampling. Basically, I want to study the population of developers. Well, better I focus on open source developers, because the general developers is a population that I cannot really count. And actually, I want to count open source developers using GitHub. So this is my population. Okay. The sampling frame is the open source developers in GitHub, because I can identify their email and contact each one of them. Okay. I have identified that in GitHub there is this number of users. Of course, I cannot contact all of them. I cannot send a questionnaire to all of them. I have to select a sample from this sample frame. Okay. So I decide to select a sample of the most active users, as I think that they represent my population better. This is a choice. Okay, I select the most active users because they are more appropriate for my research question. But how many? We just go to internet, and there is this facility for the sample size calculator that is implementing the function that I was saying before. Basically, you set the population size, confidence level, margin of errors, and you get your sample size. To get information with a margin of error of 5% and a confidence level of 95%, you need just 385 people. But let's remember that just 10 of the people respond. So I have to take 385 10 times. So I'm sending 4,000 emails. And this is what I did, actually. In the end, I got answer from 800 people. So 20%. This is not bad. And my actual sample is 800 people instead of 44 million. I can say that this is representative and is clearly above 385. And if I calculate this, if I modify my margin of error, I can see that this sample would allow me to decrease the margin of error, because if I calculate the sample size for that population, I see that with a margin of error of 4%, I have 600 people. So you see that these preliminary adjustments are really easy in the end to do. The hard thing is to get those people to answer your questionnaire, and this is depend on many factors. The alternative to random sampling is, or to probability sampling, that may be based on stratified probability sampling, as we mentioned, is non-probability sampling, that is called also convenience sampling. Okay, this is also typical in software engineering research. Why? Because very often your respondents need to have a very specific expertise, and is not easy to get this expertise from generic people. Okay, so you may want to quite precise answer that require a lot of experience. If you are sampling in a specific company, it is very unlikely that you have access to all the list of employees. So you have to deal with practical issues like this one. Same thing if you are sampling the companies in a certain area, how to get the complete list of startups in Italy or Tuscany. It may be feasible, yet quite complicated. Convenience sampling is what you adopt normally in these cases. So you gather information from all the people that you can contact through your social and professional links. So basically, if you want to consider companies in a certain area, you go in LinkedIn and you check this company, you get in contact with some of them, and you survey them. This creates also sort of bond between you and them, and it is more likely that they will answer your questions. The important thing is that you collect some demographic information together with your responses, so that you are allowed to say something about what type of population your answers represent. Because in this case, instead of starting with a very well-defined population, here basically you are surveying some subjects, and then you infer what is your scope of validity, basically. if you remember correctly. So what are the characteristics, typical characteristic of those companies that can be related to the results of your questionnaire? This is quite common to do, is more common to do with respect to the example that we saw before. So contact people, get demographic information, and try to understand what are the typical role of those people, the number of years in a certain role, number of years in that specific company, to understand what is your typical respondent and to which extent can you generalize your results. Okay. In some cases, software surveys are performed in some specific software engineering conferences, so some actors are not covered at all, because those developers, for example, that do not participate to conferences, you don't get those answers. And as a remark, you often have to rely on your personal contact with companies if you want to do research. And maybe you want to have something like a quite long questionnaire, detailed, you have to rely on your personal contact with companies and or a network of companies and make sure that you gather appropriate answer. Why? Because biased information, little information is better than information at all if the context is clearly explained. So if you are able to clearly explain the scope of validity of your results, even if you select a number of companies in a non-random way and just according to the contact of yours or your network, this is still useful, because if you can explain that context, probably the answers that you get may apply also to similar contexts. So it is true that in survey is always preferable to use probability sampling, yet in many cases you resort to convenience sampling in software engineering.